Welcome to the Pheno Flicks.
All right, hello everyone. Today we are going to be doing our first ever Pheno Flick, and we are going to be highlighting one of our very popular Shiitake strains, LE3790. The LE stands for the name of the mushroom, so that's going to be Lentinunus edotus. And our 3790 strain, I think, was just one of the first developed ones, and it was proven to fruit reliably. I think it's a fairly famous strain from Mycelia, so if it's from them, it's probably one of the best out there. And today we're just going to be going over each stage of growth. So we're going to start from the culture work, so essentially agar, kind of its rate of growth, what it should look like, temperature, some stuff like that, hop into grain bags. We're just going to be looking at the G2s today for the masters, which are just smaller, exact same process, everything's same temperature, same incubation status, same type of growth, just a larger bag. And then we're going to finally be going over our fruiting substrate blocks, which are 10 pounds. I don't think that's out there very often. And so we usually we're going to go over some yields with that one, some rates of growth with that as well, just kind of what it should look like, kind of the general processes that you'll see it evolve through. And I'm sure most people, when you order a block from us, you'll get it kind of in a ready to fruit stage already, so you might not even see all of this, but just for those spawners out there, we're going to be going through it. Cool, so let's begin just with our culture work. So we like to start all of our stuff from cryopreservation, so a negative 80 degrees Celsius freezer with 5% glycerol in it. We used to grow them on toothpicks, but we found recently that wheat grains, if you grow your mycelium on the wheat grains and they're actually able to infiltrate the rye berries, they have a certain cryoprotectant that already gets built in. So it's a little more reliable and proven throughout research papers. And so our current method is you just have a vial, fill it up with water, 5% glycerol, put in these infected rye berries, toss it in your freezer, and it's good to go for about 2 to 3 years. And so that's the start of all of these. And then we go to a slant. It's just to expand from the rye berry or the toothpick, because if we were going straight that to all of our plates that we'd use for production, we'll only have a very limited amount. By use of slants, we're just growing a little bit, and having all that surface area allows us to collect more and make about 8 to 12 pea trees just off of one slant. Specifically for the shiitakes, the mycelium grows very faintly and very loose. It's not kind of this nice white mat and it'll still grow radially and it'll create those nice circles, but the edges of everything are gonna be very hard to see. So what we've been actually transitioning to are charcoal plates, and it just lets you see that contrast way better, the white on the black, and it helps see our growth rate. And so if we want to determine how long it takes to grow, or when it's hit the edge of the plate and it's stopped growing, then we know exactly what's going on. Another thing to note, the agar plates that we use for our slower strains, so shiitakes, some lion's mane, Mycowizards of course, we use a malt yeast agar mixture from tip of the cap mushrooms. And malt yeast agar, I'm pretty sure it's just a simple recipe that he uses. It's a pretty standard one across the board. And a little bit of an idea behind malt yeast agar for the slower strains over potato dextrose is that the malt is a little more chewable, I guess is a good way to put it. So if you're a slower strain and you're kind of going out there and growing slowly, your middle parts still need all those nutrients. So if they have more that they can chew on and get access to slower, then they won't get so hurt overall. With our fast strains, the potato dextrose works fine because they just boom, take over the plate real quick and then they stop. Whereas these, they might be growing for an extra week. So we just want to make sure it's healthy and going at the right pace. And so, right, these take about 3 to 4 weeks to fully colonize and take over our plate. And so that is a good amount of time. Obviously, if we keep it in more of an incubator space at around 80 degrees or that kind of high 70s to 80 degrees, it grows a little quicker. And when we bring them over back to the incubation room, it's about 60, 70 degrees. So that's where we're gonna slow it down a little bit. Still grow fine, they still all look healthy. It's not really until you put it in the fridge that you might start getting these secondary overlayings or whatnot, because you might stress a survival mechanism or something like that. And so for the Shiitake strain, about 3 weeks or even less till it hits the outer edge of the plate. But if you're really on top of your agar and you're able to rotate stuff quickly, I would actually prefer if you took cuttings or used the plate about a centimeter away from the edge, because once we hit the edge of our plate, essentially the spread stops. So right, we want to try to capture it and spread it to our grain bag at the moment of most rapid cell division. And if we hit the wall, it's going, oh, I don't need to divide. I don't need to expand anymore. So I'll just shut that off and I'll start kind of densing up inside and making a more type of like a mycelial mat. We can even see some evidence of that on this plate already with these, this kind of white circle that's forming in the middle. You'll notice that with shiitakes that once they hit the edge and they start, or they're just kind of preserving themselves, they've hit the walls or whatnot, they will start making a secondary ring on the inside, and that'll start kind of whitening, getting a little closer to what it might look like on grain or whatnot. And even then, those can start browning and getting a little bit of color change. By then, your plate's still good, but it's evidence that it's getting old and it's maybe getting a little unhappy. We're kind of hitting our limit with our plate health. When making these plates, they're all made in front of a laminar flow hood, just so we have the best, I guess, sterile air possible, right? Not just in front of our big HEPAs that we inoculate. We're having a whole system just designed for this. All our plates are right up against that filter. And so all it is once you make your cutting from your slant, you place it on the middle of your plate, parafilm it up 2 times just to be safe, and we know it can still breathe. And then we like to leave it in the flow hood for a little bit, because right now our flow hood stays at around this kind of 70 to 80 and a little bit above area. And that's just a good incubation temperature. So we'll leave them in over the weekend, 3 or 4 days, make sure they're established, some growth has happened, and then we'll toss them into these Sacco 2 bags. Probably very recognizable, this type of filter to growers out there. And this just, again, allows for it to still breathe, so that when it's just sitting in the incubation room, still able to do all its air exchange, and that's all we needed to do at this stage. And then when we go to transfer it over to our grain bag, you simply just cut the bag open, remove the parafilm, take off your lid, and now you're all ready to start cutting your plate and making one of these guys. When we are going to make our cuttings and make our masters, we generally like to do 4 cuttings for our slower strains just to speed it up a little bit. So that would just mean front, side, and the back of the bag, just so that they're, evenly spaced, they're allowing their own sections to grow. If we're gonna do 4 cuttings, then usually we like to be safe and get only about 8 masters from a plate. We're just playing it safe. We could stretch it out and whatnot, but then we're just getting small cuttings. We might be affecting it and whatnot. But we found that about 6 to 8 is good. So from this one plate, we'll make 6 4-pound grain masters. And each of those grain masters that are 4 pounds, once they're fully colonized, break it up, and we're gonna use that to pour into our G2 or our regular spawn bags, which are 6 pounds. And so each 4-pound bag will get poured out into 12 G2 spawn bags, and then each of those 12 G2 spawn bags will turn into 20 of these. From this simple plate, we're gonna get 6 masters out of it. 6 times 12, 72, 72 times 20, 288 bags, so around there. So, you know, just this one plate, 288 bags, our yield is, you know, 3 to 5 pounds. This is 700 pounds of mushrooms, essentially. So just a little bit of perspective, again, why we use this in the flow hood, extra protection, extra safety. Anything goes wrong at this stage, just cascades down the line, you know, exponentially. All right, so if we're gonna talk about grain bags, we might as well talk about the setup, our cook, and how we prepare the grain for these grain bags. So it all starts with the type of grain. For our general mix across all of our species, we do the mix at a ratio of rye, 3 parts, 1 part sorghum, and we usually just leave it there. And then we also have been adding in gypsum and calcium carbonate. This is ordered just to keep the pH a little balanced. It creates somewhat of a buffer zone and doesn't get too acidic. And then it also just helps with clumping because grain gets very starchy. It likes to stick together. So we just add that into the mix as well. And in order to prepare our grain, we don't just do a simple soak, we do more of a boil, and so more of just like a cook, and that soaks the grains internally as well instead of doing a leave overnight method. We'll fill up a kettle all with boiling water, wait till it's at a nice rolling boil, dump in your rye, let the rye boil for about 6 minutes, turn off that heat, 12 more minutes of just kind of sitting, chilling in this very hot, you know, near boiling water. Then we drain the water, dump it all out, and get it ready to dump into our mixer. And this helps us achieve that ratio of about 40 to 50% moisture content, because, right, the whole goal of grain is we just want as much water in that grain without causing bursting. And so the Milo just, boom, sits in the boiling water for a cool 20 minutes, drain it, and it's good to go. We check all this moisture content with weight. So we have our scale right there. We weigh out the draw weight. After the boil, put it on the scale. Cool, we hit our moisture content. So as long as we hit that above 40%, we know it's probably not gonna be too dry. Cool, the grains aren't bursting, so we can prevent stroma. We mix it all inside of our big mixers, and then we have a pneumatic bagger that measures our bags volumetrically. And so you have your volumetric bagger, come up, fill up your bag, toss it on the scale, make sure we're at our 6 pounds, boom, good to go. And next it goes off to our Primus, or the vacuum autoclave, which is a little unique to us. I'm sure more and more people out there are doing it if they have spawn laboratories. But the vacuum autoclave, we have a vacuum cycle in the beginning. So boom, pulls a very strong vacuum, negative 10 inches mercury, and then it comes back up, and as it's coming back up, we sucked out all that air, pump in steam to bring it back up to a pressure. We're just trying to create that kind of nice steam pressure correlation with these vacuums. And about 3rd or 4th vacuum, the line syncs up and we're all good to go to just shoot it to the top. 255 degrees Fahrenheit is what we like to aim for, and we do it for about 35 minutes. Granted, you know, sterile or normal sterilization, they recommend 15 to 20 minutes above 120 degrees Celsius. So we're hitting our limit on our Celsius, but then we're just being extra safe, cooking it for a little extra. Doesn't affect the grains too much. We still run test bags. They maybe gain a little bit of extra water from the steam getting influxed in, but overall we still are staying in our limit. Everything looks healthy. After the autoclave, our bags are sterilized, you pull them out, and they're ready to get inoculated. When we're ready to start our inoculation, after those are sterilized and everything, we have our 1 4-pound master, and it's gonna inoculate 12 of these 6-pound bags. And so, you know, what that looks like, lab table, HEPA filters, lay out your 12 sterile bags, open them all up, then boom, slowly pour through. Obviously try to make it even. Nobody's perfect. We don't have like a scale and measure it out each time. And also with these bags, just as long as you get a good little section in there, right? A couple grains won't do it, but if you get a handful, it'll fully colonize the bag with proper shaking. Make sure that that grain spawn gets all nice and throughout all the other grains inside of the bag. And then it, boom, goes up on the shelf, sits there to incubate for 3-4 week. A little bit slower than our agar, just a little more surface area. And also there's a couple different stages of growth that are happening when we are inoculating these bags. So we first inoculate them, and we're just gonna have a bunch of individual infected pieces of grain that are all spread throughout the bag. So when you're looking at these bags originally, you'll just see the white spots, and then maybe after a couple days or 4 or 5 days, you'll see these white spots are starting to expand a little bit. We're not gonna be nearly at this stage of fully colonization. It's just gonna look like a bunch of grain in a bag with some white dots slowly forming. And then, you know, this goes on for about a week, week and a half, nearly 2 weeks, you know, always dependent on your growing environment and whatnot. But for us, for shiitakes, it's about a week and a half, 2 weeks until you'll start seeing those threads take over the whole bag. And at this stage, or I guess right before that stage, you can go up and feel your bag and it'll almost feel loose, like all the grains aren't really connected. It's not necessarily a block yet. It's still kind of all these loose threads, but now they're just kind of touching all the grain. They haven't really established on all of the grain yet. So that's where we're at, about 1.5, 2 weeks. It'll start taking over and it'll look like there's white and there's wispiness all over the bag, but there might still, it's not quite a block yet. It's still loose. Like if you went up to it and gave it a squish, it would just explode into a bunch of individual pieces. After that stage has happened and we see the whiteness, this wispy whiteness kind of take over all of the bag, then it'll start to kind of, I like to say, double up essentially and just start making more of a mycelial mat around the entire bag. So that's when you'll start getting more and more of these kind of denser white spots. If you look at the top of our bag, then we get a lot of still wispiness on the grain and whatnot, but all this stuff that's down and internal, it's starting to look dense. So you can still see wispiness, but there's definitely some whiteness that's appearing. At this stage also, you'll maybe start to even get some little yellow metabolites, secondary metabolites that appear. That's all normal. It's just the fungus doing its thing. Just these older spots are, you know, oh, I've been established on this grain now for maybe a month if I was one of the G1 grains. So I'm not thinking about expanding. I'm just gonna try to exist and create all these secondary metabolites and whatnot. So if we were just to let this block exist in our incubation room and never take it out, we would get to this stage and it would start getting more and more of these metabolites around. And also you might start notice some popcorn or buckling of your bag, which will just kind of look like little indents, or yeah, like pieces of popcorn are almost kind of starting to appear on the sides of your bag. At this stage, you have to be careful if you're spawning it, because here we might even be approaching auto fruit stage. And with shiitakes, they're very, oh, I've switched to this genetic, I'm an auto fruit. I'm not gonna go back to my spreading stage. I've decided this is where I'm at. And so we don't even ship a bag if it's got a single fruit on it from this stage. If we don't have any evidence of fruit and there's buckling and maybe even like a little bit of brown, you could still use that to make your own substrate blocks. We just don't prefer to do it for customers, but we'll still use those in-house if there's no evidence of fruiting on those blocks. So really we like to catch it before that stage. Maybe there'll even be a giveaway. Some of the blocks on the rack will have that popcorn effect. You're like, oh, cool, gotta get this rack out of here. And when we say out of here, into our reefer units or our cool down rooms, it's stored at about 35 degrees Fahrenheit. So, all right, we're just above freezing because 32 degrees Fahrenheit. And so we're not trying to freeze the blocks because obviously then we'd freeze all the water inside the mycelium and just injure all the cells. So we bring it just right down there, and this just puts all the mycelium in a lower state of metabolism. So instead of munch, 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 and it's just trying to eat and grow, it goes kind of more hibernation. It's a grizzly bear that's fully fed, and now it just wants to kind of sit in its cave and exist. A good way to think about it as well is you don't want to wait and go, cool, they're all popcorning. That means they're just about to go. I'll toss them into my reefer unit, because our reefer units, right, again, just slowing it down. So even though we're slowing it down, that metabolism is still going a little bit. It's still doing something. So if we kind of catch it before that stage, we have this nice dense block. It feels solid. There's white everywhere. We're even getting this dense white in a lot of places. You can probably go, cool, that's good to just go sit in the reefer unit, and we'll just have to keep an eye on it in case it does try to do something weird or whatnot. And we just keep them in there because now we've slowed it down, we've deemed it good, and now it's just waiting to be shipped out. So our fruiting blocks, with all wood rot fungus, you need some type of wood in order for it to actually make fruiting bodies. They're 10 pounds and they're consistent by weight of 30% crushed up wheat, right? Just kind of powdered wheat, and then 70% of red oak sawdust. And for the mix for these ones, I kind of put parentheses around it because it's nothing like the grain. It's just water and the substrate. That's all it is, goes in the bag. Doesn't even really get a shake. They'll just maybe get a little fluff to make sure that water gets in, fold it over, and then these bags are pasteurized instead of going through this big vacuum sterilization process. Little reason behind that, again, as we said earlier, one of these making 20 of these. So if one of these is messed up at all or has any infection, we just ruined 20 bags, which, right, 60, 80 pounds of mushrooms that we just are no longer able to create. And so also pasteurization has been proven. It was the majority method that was used throughout time of cultivation, I guess. And with that, all these just go in there and it sits in steam loosely, just right. We're not pressurizing it. We're doing pasteurization. So it sits in the steam for about 10 hours. And then after that, we've done the tests, we've done the data loggers, we can prove that it does reach up to a sterilization temperature, but we're not keeping it at that 15 to 20, really like 15 to 20 minutes and really like ensuring pure sterilization. You just go up, boom, good enough. It's never caused any problems for us. Steam boxes are popular everywhere. So our steam box is right next to our substrate lab. Same setup in terms of the inoculation. It'll just be one of these bags instead of a 4-pound one of these bags. And we'll lay out 20 of these across the lab table with the wall of HEPA filters, open them all up, break this guy all up. It's okay if we break it all up and we're gonna be using it to still expand. If you already have a fruiting block, you never wanna break it up. You wanna just have it sitting there and it's just gonna do its thing. If you come up and start messing with it, you're breaking threads, you're hurting the primordias that are forming these dense mats where mushrooms will eventually fruit out of, and we're just messing up the whole process. But if we break up a spawn bag into all those individual grains just all the individual grains again, we split it up, they're all separated, they're all alone again, and they go, oh, okay, I'm in somewhere new. Oh, I can eat this? Cool, I'll just start expanding again. You can still get a good amount in each bag, and even with the little bit, we've had success before, so whoever is your knocker, just make sure that they're a little bit even with their pouring and everything. And so once these get done and they're inoculated, we send them out to the shake table. Everybody there shakes them all up just to, again, same concept, spread all that grain around, just make sure it evenly gets all throughout the bag so that when these grains are expanding, they aren't just all gathered over here and now this side of the block gets nothing. We just want the whole block to get nice and fully expanded upon. Once we've done that, we hit our incubation phase for our 10-pound substrate blocks. And so again, these are ready to fruit. They have all we grow our wood rot fungus. They have that wood in there. It's very dense. It's very lignocellulose concentrated. We just need to put it on the shelf and let it do its thing at that point. Again, these growth processes are very similar to our grain bag that we discussed earlier in terms of how it should look. So with our substrate bags, just looks like a bunch of dirt in a bag essentially, just a big brown block, but it'll still be very loose. And then about that first 1 to 4 weeks of incubation, the total incubation time for these is about 12 weeks. Give or take temperature conditions, hot, cold, all that, but around 12 weeks is our general flipping around period. So this first 4 weeks, we're gonna have that individual pieces of grain getting onto their substrate, going, oh, okay, cool, I can't eat this, and they're just gonna slowly start spreading out in that wisp, very similar to our agar plate as we discussed earlier. Start growing out from these wisps, from these individual grain, and in that first 1 to 4 weeks, it's just taking over the bag. It's taking over the inside. It's not just creating a mat all over the outside. So it takes a little while for all of this to go through and complete. and then it takes control of that bag. Again, the bag will look like a block. It will probably have some white like throughout it, but it might not be this dense white or this fully formed block. If you went up and gave it a little squeeze, it would probably still break on you. And then again, now we're just messing up our fruiting body production at that point. So after those 1 to 4 weeks of growing these wisps and this more kind of agar look to the bag, then in that 4 to 8 weeks, that's when we're gonna start getting that densening of the mycelium. It'll be pretty similar to what this guy will look like throughout that 4 to 8 weeks. Come by the end of that 8 weeks, you might even start getting a little bit of popcorning and browning or kind of these things, but these are all good things for our case of fruiting, because those are all the evidence that it's working, it's going through its life cycle process, and it's moving along healthily. So at that stage, at the end of that 8 weeks, if your bag is fully nice and white, and you're even starting to see maybe some of these little yellow metabolites and whatnot pop up, you're in a really good spot. And so that last 8 to 12 weeks is where, don't freak out, but it might start looking a lot different from other production blocks. And so what I mean by this is that we'll start as this nice white, thick mat, and then it will slowly start to popcorn and buckle. Again, just kind of looks like popcorn's coming out of the bag. And when we say buckling, like the substrate itself, you might even see it kind of moving, or not, you won't see it move, but come in the next day and you're like, oh, it's kind of lifted this way or shanted that way. And from here, you're still all in the right. Bag should look nice and white. You know, just keep looking out for any obvious infections or whatnot. And then in that kind of final process, your bag's gonna start getting real brown. And this will just take over the whole bag over and over, but that's all okay. This is just the shiitake doing its thing. It browns, and then once the bag is fully brown, it goes, cool, I'm now in my fruiting stage. I've buckled, I've popcorned, I'm fully myceliated. Oh, I'm even starting to densen and brown out. Cool, now I can just start making fruiting bodies. And so that will be kind of that last, 11th, 12th week. You'll have a fully brown bag most likely, and you'll even start seeing all these little pins that are starting to come out. If we kind of let this continue in the bag for too long and these fruit bodies kept pushing and pushing out, they'll just keep growing. And so you'll just end up having a bunch of smushed up shiitakes kind of pushing up against this bag. And you don't want to send that to a customer because it's already done its first flush at that point. We want it fully browned, send up maybe a little bit of pins, but just send it off. And then when they get it to their facility, they can have it so they're in full control of their pinning method, what they're going for with their moisture or their humidity and whatnot. Okay, so let's take a look at some of these blocks, just so you get a little bit of a better idea of what I'm talking about. So, block on my left side. This is about where we would want to ship it out to a customer. So the block is fully brown, right? We're still getting some white bit, but essentially that's a fully brown block. Most of it's not pinning, right? We have some evidence like, oh, look, it wants to start over on that end, but those are just the heads coming out. We have no type of stem formation, just that little bit of cap that's trying to push through. And also you can see a little bit of this popcorning and crumble effect. See how it just kind of comes out in these sections almost, these folds that it's emerging out of, whereas your usual block might just be a nice smooth myceliated block. This one gets all crumbly. And so yeah, this is our prime shipping out at this time period. It's all good to go, fully browned, and then the grower can do what they want and form those fruit bodies how they want. Over here on my right side, we're getting a little to the dangerous zone. We probably wouldn't ship this out unless it's to a customer who comes and picks it up directly, or they request something like this. But as we can see, all the fruit bodies have started to develop. The top of the block is actual substrate. So, right, we have that fully browning effect that's going on, and we're starting to just get pins all over the block. And so from here, they've already started fruiting. If we just left this out and we came back in 3-4 days, this might just be a fully formed block of edible shiitake. So, right, we don't want to ship that out to someone, say it takes a day or two to get to them, and these are all just growing in that bag more and more. All of our caps will start getting deformed, they'll start getting smushed. And yeah, another thing to point out, again, right, we're having that stem formation already, and we kind of want to avoid that. We're okay with the pins, but we're not okay with a full stem that's appearing. Unless you were growing it, of course. And so that was pretty much the review. We went through our culture work and our agar, how that gets transferred onto our grain bag and about when, general times for our grain bag, off to our fruiting blocks, and then a little bit past our fruiting block stage. And that was the LE3790.
Thank you, Gregor. I shall step in for some substrate examination for Lentula edotis 3790. Funny backstory about this in particular strain is we were growing a lot of 3782, and that's sort of like, I'm assuming, the cousin or the runner-up to 3790. I know that both of those strains in particular came from Japan, and then Mycelia and a few other companies went over there and yanked them. Japan doesn't take too kindly to that, but I think it's all good now. And 3782, as you can see some pins forming on this block, produces a lot of smaller pins, and they're almost like a thinner cap, whereas 3790 prefers colder weather to fruit, but does actually produce a heavier, more dense, sort of donko-ish mushroom. In terms of the quality, Far West Fungi grows this exclusively. We do, as well as a lot of other farms out there who've kind of found their niche with this variety. So when it comes down to substrate mixtures, the majority of farms have found their balance in about 30% wheat midds or wheat bran substrate with about 70% red oak or some other hardwood like an alder. That in particular makes a really kind of softer, less hot substrate mixture, and it allows for the three different metabolic stages of colonization for a shiitake log to properly colonize prior to fruiting. One of the most important things to understand about shiitake is if you don't understand the three different phases of metabolism in the fruiting substrate in particular, you will get to a point at which the block will fully colonize, it will buckle, and then it will brown, but it will never fruit mushrooms if something went array in that. So to give you an example, we ultra pasteurize these blocks. So we get them up to temp, which is about 205 to 210 Fahrenheit, and we hold it for 3 hours before immediately cooling those blocks down in our laboratory. When we do that, there's still the chance of thermophilic bacteria, those like hard to kill bacterial endospores existent within these blocks because it's not truly sterilized. So we have to keep our incubation temperatures down around 66 for two reasons. That thermophilic bacteria might be present, and these blocks are so damn big that they produce a lot more heat. So from the center of this block all the way to the outside can be about 4 degrees, maybe 5 degrees temperature differential. So if it's 70 on the inside, on the outside it will be a bit cooler, but say it's 70 on the outside, it's 75 on the inside. That's not good, specifically for this process in this block, because those thermophilic bacteria start to kind of like come up and creep in at 75. So how you know your block is sort of in a good stance is to let it fully colonize in the first 1 to 4 weeks. In that 4-week period, the block will basically start to leap off and almost look similar to this grain spawn, but a little bit lighter. And then it will start to densen up. And as it denses up in this sort of camouflage fashion, you're gonna see these patches of colonization give way to buckling, and almost from far back, you can see these white spots that are pins. It forms this like textural element. It's almost like levitating bread or something. That's a separate stage, and that happens between week, say like 5 to 8, somewhere in there for 3790 in particular. And by week, I would say 7 to 12 is when browning starts to happen. The interesting and cool part about browning is that it's a light-based reaction. So if your substrate in particular for shiitake is not exposed to light, you'll get almost no browning whatsoever. And light exposed on all sides of the block, just enough so that if you can see the block can brown, so to speak, the block will fully brown and sort of be prepared to be called fully mature over that 12-week period. This block is at a perfect stage at which we'd want to ship out. You can see some pins are starting to form, just like little brown dots, and behind them, little white stems. We kind of want to make sure they're fruiting before we send them out to a degree, just to make sure nothing happened to these blocks. Give it a few more days and the whole block will be covered in pins just like this. One of the things we don't want to do is ship blocks at this state, because the bag will be wrapped around so tight that these mushrooms will just get malformed and kind of ugly. And truth be told, if they're sort of suffocated by the bag that is trapping CO2 inside, they won't be able to actually breathe very well. So you'll get these misformed caps and sort of gills that never emerge, and they're just kind of ugly fruits. But if a farm gets it between this stage and this stage, they just strip the bag, they soak the block down with water, and within like 5 to 7 days, the block is fully bursting with pins. It's one of the longest to incubate blocks to make sure that it goes through colonization, buckling, and browning. But once it gets to the stage of fruiting, it's like 5 days. 3790 in particular likes colder weather. So cold shocking these blocks or storing them in refrigeration will dampen the metabolic rate, and it will cause sort of a delay in pinning. But you don't want to sort of keep them in the cooler too long, because no matter what, they're gonna pin and they're gonna fill that bag up with mushrooms, and malform ones for that. So once you've harvested them, grade them, pack them. A cool fact about 3790 in particular is that a long time in Japan, it was like one of the most sought after and utilized varieties because it produced the most grade A shiitakes. And in Japan, they're the most picky when it comes to shiitakes, and there's something like 30 grades of shiitake. So this one in particular, it produces really nice fruits, especially when not over supplemented and when properly, prepared, ultra pasteurized or sterilized, incubated at the right temperatures, and then allowed to fruit in a timely fashion so that the forming fruit bodies are beautiful. So that's 3790. Thank you for another Mycowizards Pheno Flick episode. See you next time.